Hey guys, welcome back to geometry. Um, this is take two. When you get through an entire video and then at the end you realize that you had your microphone set to a different microphone and didn't plug it in, it can cause some problems. So let's try again, shall we? All right, so today we are talking about angles. More specifically, we're talking about how angles relate to one another. We want to be able to compare these two things so we can then use them to solve for objects. So the first thing we're going to talk about are these guys right here, vertical angles. Vertical angles. So vertical angles are going to happen whenever you have this sort of X with these two lines. Whenever you have this X shape, you're going to have vertical angles, okay? So corresponding angles are going to happen over here. Corresponding angles, we have a parallel line and another parallel line. Now, those parallel lines are cut by a third line that is called a transversal. Whatever one line cuts through two other lines, it's called a transversal. Okay. Now, if you notice, if you kind of imagine zooming, zooming in. Actually, I can do that. So if you just kind of zoom in on this little part right here, okay, you'll notice that that's that same sort of X shape. That same sort of X shape. So we have vertical angles happening here as well. Same thing with if we take it down here. We have another set of vertical angles happening down here because we have a line and another line. Okay, so one thing to keep in mind, this shape right here, this sort of two parallel lines cut by a transversal, is one of like the favorite things of geometry teachers, geometry tests, and that sort of thing. So this thing is gonna keep coming back, which means a couple things. If you don't get it right away, you're going to have plenty of opportunities to figure out what's going on. The other thing is, you really want to make sure that you have all this stuff sort of stone cold right in you, able to be pulled out at a moment's notice, because it will come up again. Okay? So with that, let's jump in and take a look at some vertical angles. Vertical angles. Again, the angles we're talking about with vertical angles, the angles that are opposite each other when two lines intersect. Those are called vertical angles. Okay, so let's take a look at like this angle here. All right, I'm going to call this angle right here. This is going to be angle 1, and we'll call this angle 2. So angle 1 and angle 2 are vertical angles in this situation. All right, I'm going to be kind of not 100%, what we've been doing. And I'm going to call this guy right here, actually let me use a different color because that's not super visible. Let's go ahead, I'll use this sort of color. Not much better. Okay, don't worry, I'm going to figure out this color thing. Here we go. Yeah, there we go. All right, so this guy right here, we're going to call this angle smiley face. I know we haven't given that, sort of any, names or anything yet, but we're going to call this angle star. So angle smiley face and angle star are also vertical angles. Okay. So the nice thing about vertical angles is they are congruent. They are congruent, which means they are congruent, which is that funny little equal sign with a squiggle over the top of it. But we can also say that the measurements of these angles are equivalent. So when we're writing these out, our measurements of these angles are going to be equal, which is nice because that allows us to solve some problems. So let's solve a problem or two, shall we? So first off, let's see if we can figure out what is the value of x. What's the value of x in this situation? So if we take a look at our shape here, we have two sets of vertical angles. One of them is measured at 5x plus 48, and the other one is measured at 4x plus 21. So since they're vertical angles, they have the same measurement, we can set them equal to each other. 5x plus 48 equals negative 4x plus 21. So go ahead and give it a shot to see if you can figure out what value x should have in this situation. Okay, hopefully you gave it a shot. and we will say, go ahead and add 4x to both sides. In order to unsubtract that 4x from both sides, we're going to add 4x to both sides. So that's going to leave us with 9x plus 48 equals 21. Those 4x's are going to go away. And now let's subtract our 48 from both sides. Minus 48. And then we have 9x equals 21 plus negative 48. 21 minus 48 is negative 27, which means that x, when we divide both sides by 9, sorry, I'm running out of room, x should then equal negative 3. Okay, so there's our value of x. But you might be thinking, well, we have a negative number. We're dealing with angles. How can we have a negative number? Okay, well, at that point, if you're ever not comfortable with that angle that you found, plug it back in. See if you can find an angle that makes sense. So that's what this yellow question is over here. This yellow question is asking, does that number make sense? So if we take negative 4, and then we found x to be negative 3, so negative 4 times negative 3 plus 21. Negative 4 times negative 3 is positive 12, because a negative times a negative is a positive, plus 21. If we then add those two up, we get that the angle measurement is 12 plus 21 is 33 degrees. All right? So, yeah, 33 degrees makes perfect sense for that sort of angle. So it's absolutely fine. You can have negative numbers. You can have decimals. You can have fractions. You can have any kind of number there. But just check it and make sure that it makes sense. Oop, I am sorry that I was obscuring the answer there. My bad. That's on me. All right. So let's move on. Talk about some corresponding angles. And here I come. I'm back. Hi guys. Did you miss me? I did. All right. Corresponding angles. Again, we're looking for when two parallel lines, parallel line 1, parallel line 2, are cut by a transversal. This doesn't matter. This orientation of this thing doesn't matter. All right. It can be twisted, turned upside up, down, left, right, anything like that. Doesn't matter. So when you have two parallel lines are cut by a transversal, angles that are in the same position on both of the x's. So like if we count this, we count this guy as x number 1 and this guy as x number 2. The angles that are in the same position on both of the x's are called corresponding angles. So I'm going to use some colors and see if we can sort of identify where these are. So if we take a look at this angle here, that corresponds to, that is in the same position as this angle here. Likewise, if we take a look at this angle here, this is in the same position as this angle here. If we take a look at this angle down here, and we look up at the other x for this position, we're talking about this angle here. All right. And last, but certainly not least, if we take a look at this guy over here, it's in the same position as this guy over here. Now, you'll notice that I started at the top and went to the bottom for some of these, and started at the bottom and went to the top for some of these. It doesn't matter the direction that you move, but as long as they are in the same position, so like green and green, purple and purple, yellow and yellow, red and red, as long as they are in the same position on both those x's, they are called corresponding angles. You could almost say we want to almost just take this picture, we want to take this x here and be able to just drop it right on top of that other one and have the colors match up. Okay? The nice thing about corresponding angles, just like vertical angles, they're also always congruent. They're also always congruent, which means they have the same measurement. If they have the same measurement, we can set up equations. So let's do that. So here we have three angles. The first angle is called is 6x. The second angle is called 2x plus 72. And then we have our third angle that is just called angle y. All right? So let's start with x. Because if we try to start by finding y. We just don't have enough information to do that yet. So we're going to start by finding the variable x. All right. So 6x and 2x plus 72 are in the same position on both of these x's. So this x right here and this x right here. If you look at sort of like the top left position for both of them, you get this 6x and this 2x plus 72. Oop, thought I was going to sneeze. It passed. Don't worry, everything's okay. All right. So 6x and 2x plus 72 are corresponding angles, which means they're congruent. So we can say 6x should be equal to 2x plus 72, which usually starts with a 7. 72. All right. So now we're going to solve this and try and get x by itself. Well, first we're going to subtract 2x from both sides, leaving us with 4x on the left, equaling 72 on the right. And then if we divide both sides by 4, x will then equal 18. So what's the value of y? Well, the value of y, once we found that x should be 18 in this situation, the value of y is going to be, I lost my color. I think it was this one. Nope. Whatever. So the value of y, we have to figure out what these two angles, how are these related? Well, these are both on the same side of a line. There's this angle here, and then this angle here, if you trace them and follow them with your finger. So those two angles add up to be a straight line, which is 180 degrees. So if we take 6x and we add those two angles together, so 6x plus y equals 180 degrees, that should be our angle measurements. So now we know that x is equal to 18. If we tried to do this before, we just don't have enough information to plug stuff in and find either x or y. So 6 times 18 plus y equals 180. So 6 times 18, so let's see, 6 times 10 is 60 plus 6 times 8, which is 40. So 60 plus 40 is 108 plus y. I know that kind of looks like a 4, but it's a y, equals 180. So now we want to get y by ourselves. We're going to subtract 108. Yeah, I nailed it. And we're going to subtract 100 and, wow, I did it again. 108 from both sides. So y is then going to be 180 minus 108 is, let's see, 80 minus 8 is 72 degrees. Okay, so angle y is then going to be 72 degrees. All right, and again, we could plug everything back in. If we say that y is 72 degrees, 72 plus 108 is going to give us our 180 that we're looking for. Okay? There's a couple examples of the types of problems that you can find with these. Hopefully that made sense. If it didn't, we are going to be we're going to have live time. Feel free to shoot an email, but get those questions answered. Okay? Don't just sit there and stew. Have these answer these. Ask the questions. We'll help you. You'll get there. We believe in you. Thanks so much. Have a great one. Look for part 2 coming up shortly. Okay, bye.